Hey everyone, my name is Kingsley, and today I'll be doing problem 4.
Number 4 says evaluate the following by completing the square, and it gives us the integral of 1 over the square root of x squared minus 18x plus 97 dx. And the first step we need to take to evaluate this integral is to complete the square. So we take the polynomial that's inside the square root and we bring it out here, and then we rewrite it so that all of the x terms are inside parentheses and the constant is left out. And to complete the square, we take half of the x value without any exponents, we divide that by 2, and then we square it, and we add it on. So half of 18 will be 9, and then we square it. And since we added this 9 squared here, we need to subtract 9 squared from the whole thing just to make sure that it stays equal to x squared minus 18x plus 97. And so what we get here is 97 minus 81 is 16, and then the factored version of this polynomial is x minus 9 squared. So the completed square is x minus 9 squared plus 16, and then we just add that on to the integral here. So now our integral is 1 over the square root of x minus 9 squared in parentheses plus 16 dx. And then we need to integrate this integral using u substitution, and our u will be x minus 9, and then our du is just dx. So then our integral comes out to be 1 over the square root of u squared plus 16 du. And then I rewrote it as the integral from 1 over the square root of u squared plus a squared, where a is equal to 4, just so I can get it in the correct form for a trig substitution. And I have the three of those written out here. And the one that matches up with our equation is the square root of a squared plus u squared, is where u is equal to a times tangent theta. And then, so our u will now become 4 tangent theta, since our a is 4, and then we take this equation, so it's just 4 times tangent theta. And then our du is equal to 4 secant squared theta d theta. So then we take the denominator of our fraction up there, and we plug in for u squared 4 tangent theta squared plus 16, which after we square what's in the parentheses, we get 16 tangent theta plus 16. We can factor out the 16 out of everything, and tangent theta, or tangent squared theta plus 1 is equal to secant theta. And then when we square root all of this, we get 4 secant theta. So then we plug that in for the square root on the bottom, and now our integral is 1 over 4 secant theta times our du, which is 4 secant squared theta times d theta. And then we bring this up onto the numerator, where it will cancel the entire bottom half and then get rid of the squared on the secant. And so our new integral becomes secant theta d theta. So now we have to integrate secant theta d theta, which is ln times the absolute value of secant theta plus tangent theta plus c. And this is just one of those given antiderivatives, just like how 1 over x is ln x. But now we have to convert the entire thing back to x. And we can do that by finding secant theta and tangent theta, and then just plugging it in. And we can find tangent theta pretty easily, since previously we found that u is equal to 4 tangent theta, and then we just divide both sides by 4 to find that tangent theta is equal to u over 4. But now we have to find secant theta, and how do we do that? Well, what we can do is create a right triangle where we found theta, or tangent theta, and it said that it is u over 4, which also means that u is the opposite side and 4 is the adjacent side, since tangent is opposite over adjacent. And you can draw that angle either here or here, it doesn't matter, you get the same answer either way. But let's just say you draw it here, and your opposite side is u, and your adjacent side is 4. But we know that secant theta is hypotenuse over adjacent, since it's the inverse of sine, and we can use the Pythagorean theorem to find the hypotenuse. So we have a squared plus b squared equals c squared, and I'll plug in 4 for a and u for b, so it's 4 squared plus u squared equals c squared, and that comes out to be c is equal to the square root of u squared plus 16. And since our adjacent side is 4, secant theta is the square root of u squared plus 16 all over 4. So now we just plug our values for tangent theta and secant theta back into this equation here. And now we get ln times the absolute value of, oh no, not ln times the absolute value, sorry. Ln of the square root of u squared plus 16 over 4 plus u over 4. And since both of these have the same denominator, we can just add them up to u plus square root of u squared plus 16 all over 4. And if we want to simplify this further, we can use the rule that says ln of a over b is equal to ln of a minus ln of b. So now we get ln of the numerator, which is u plus the square root of u squared plus 16, and the denominator, which turns out to be plus ln of 4 plus c. But ln of 4 is a constant, so we can just group that in with the c that's already here and simplify it even further to ln of u plus the square root of u squared plus 16 plus c. And now we plug in our u's from our first u substitution on the previous page. And so our u is equal to x minus 9, and then the u squared in here becomes x minus 9 squared plus 16. And right at the beginning, we found that x minus 9 squared plus 16 is equal to x squared minus 18x plus 97. So our final answer is ln of x minus 9 plus the square root of x squared minus 18x plus 97 plus c.